Okay, well, welcome to Tuesday. I am going to, yesterday what I did was I took it really slow, and I'm going to do that again today. And what just to refresh, what I did yesterday was I talked about interior angles, and central angles. And if I just flip the page again, remember what a central angle is? If you take a pencil and connect all the corners, all the vertices of a shape to the center, it creates a little pattern in the middle, and all of these angles that start at the central angle. That makes sense. And then an interior angle is, without all those little lines drawn connecting to the center, an interior angle is just the angle created at all the corners. So we also notice that a five-sided shape has 5 corners, so we have 5 interior angles. It also has 5 central angles. Okay, we talked about the two formulas that we used, and I assigned a couple of questions in the homework, and I guess I'll just wait and see if in the chat if there's any questions on the homework I assigned. And if not, what I'm going to do is I'm going to go talk today about exterior angles and diagonals. And that's it. I'm just going to keep it short again today, just talking about 2 topics a day. So if I talk about an exterior angle, the size of an exterior angle, remember an interior angle is the ones inside the shape at the corners. And an exterior angle is... Exterior means outside. So an exterior angle is formed in the space between the extension of one of the sides with an adjacent. If I took any side of the shape and I just continued the side and just kept drawing it, right? On either side, I mean, it could be on this side too, but in the diagram, they've extended it here. Well, if I extend the side, any one of the sides of a polygon, it automatically creates another angle, okay? With the extended side, the extra part of the line, and the polygon itself. So that's called an exterior angle. So the word is important to know, the word exterior angle. So exterior angle, but the formula is really easy because you don't really have to learn a new formula. You just have to learn that applies for exterior angles. It's the same size as a central angle. So exterior angle is just 360 divided by n, and n is the number of sides of the polygon. So it's the same formula we used for the central angle. Okay? Note, this is the same formula we used to find the central angle. Okay, so we're still talking about a 5-sided shape, pentagon, 1, 2, 3, 4, 5. So n is 5. Calculate the size of the exterior angle in a pentagon and fill in the size in the diagram above. Okay, so the exterior angle, the size is 360 degrees divided by 5, right? For a pentagon, n is 5 because there are 5 sides. Okay, so yesterday we noticed that if I take 360 and divide by 5, each exterior angle, it doesn't matter what side's extended, it's just the extra piece of the line and the angle that's created by the extra piece of the line and the pentagon itself. So this exterior angle is also equal to 72. All right, so that's very easy if you did yesterday's homework, right? It's the same formula. So I'm going to keep adjusting. Now let's talk about a diagonal. I'm just going to do those two today, and then maybe we'll take a look at some of the questions. So find the number of diagonals. So that's the second new word today. First new word was the exterior, as an exterior angle. And the second new word is the diagonals. So what is a diagonal? You might have seen that word in other parts of your life, but a diagonal of a regular polygon is a line that connects a vertex. So remember, these are the vertices. It connects a vertex to any other non-adjacent vertex. Below is our example, pentagon with your teacher drawing the diagonals. Okay. Well, when it means non-adjacent, this vertex is right beside this vertex, right? Well, that one's already connected, so I don't have to redraw. That's not a diagonal. From here to here is not a diagonal, it's a side. So I'm going to take my ruler and I'm going to connect all the other vertices to every other corner. This one's already connected. This is my first diagonal, right? This corner to this corner. Then I'm also going to have this corner to this corner. Okay, and these two are already connected. So that doesn't count. So I have 1, diagonal 2. Okay, let's go to this vertex. This vertex is already connected. So I'm going to connect it across. And I'm going to connect it to this one. Each vertex gets connected to 2, right? Okay, and it's already connected to this point. Okay, let's move to this vertex. This is a side. This is already connected. Let's see. And this vertex is already connected, and this vertex is already connected. So in total, I had 1 diagonal, 2, 3, 4, and let's see, 1, 2, 3, 4, 5, 6. Right? I have to see if I did that right. Let me try this again. I should have been drawing when I was, okay, diagonal number 1, diagonal number 2. Okay, so that's 1 and 2. And then diagonal 3 and 4. And then, this isn't diagonal 5. Number 5 was already labeled as 2. Sorry about that. I knew I was 1 extra. This is already diagonal 5 and more. Okay, so 1, 2, 3, 4, and 5. So the number of diagonals seems to be the number of sides again, right? But you can calculate the number of diagonals in any regular polygon by using the following formula. So here's our new formula. This is kind of a new definition of our formula, but it's the same formula as central angle. So this is our only new formula for today. The number of diagonals equals n times n minus 3 divided by 2. N is the number of sides of the regular polygon. N will always be the number of sides. So let's see. I drew them all and I got 5. Let's use the formula now. The number of diagonals, which is D, equals, and remember pentagon, n equals 5. So I'm going to have 5 times 5 minus 3 divided by 2. Now, if you've got a great calculator and it's easy to work with, you can use your brackets. If not, I'm going to clean this up a little bit. Okay, so it's going to be 5 times 2 divided by 2, right? Okay, I guess I could even go a little further, right? 5 times 2 is 10. All right, and let's use our calculator. 10 divided by 2 is 5. So again, that's what we got, right? 1, 2, 3, 4, 5. We didn't have, these aren't regarded as extra diagonals. Once you've drawn them, they just count as one diagonal. So that's our second formula. And what I told you yesterday was you're going to be able to use that formula sheet. Hopefully you have it. It makes it a little through the booklets, right? So if you have your formula sheet, and I think I made sure everyone had it, I would just have this beside me through all the questions that I'm doing, because it's all got all of our formulas, right? The sum of the interior angles, one interior angle, an exterior angle, and a central angle. Notice they're the same. And then the number of diagonals, okay? So that's very helpful to you when you're working through your booklets. Let's take a look at some of those questions from yesterday. I guess I could just fill in this last one. The number of diagonals is 5. Talking today, I don't want to do lines of symmetry. I'll do lines of symmetry tomorrow, and then there's some backwards questions. And again, it summarizes here all the formulas you should know, but they're nicely written out on your formula sheet anyway, so I don't know if that's if this is totally necessary. Let's take a look at some of the homework questions, and then I'm going to assign a couple more questions for you today. So let's just take a look. I assigned number 1A to D, and I'll just kind of quickly go over those with you. If you are ready to do more homework, I'm going to assign number 3 to 5 today. So number 3 on page 15, do 3, 4, and 5. I'm going to do number 1 and 2 with the for anyone watching. So let's take a look at number 1. An octagon is an 8-sided regular polygon shown below. So 1, 2, 3, 4, 5, 6, 7, 8. So right away, if it says 8-sided, I know that n is 8. And knowing what n is very important because n occurs in all the formulas. Answer the questions below the diagram. Calculate the size of a central angle. Okay, so part A, that's just going to be 360 divided by 8. So use your calculator. 360 divided by 8 gives us 45 degrees. Okay, so the size of a central angle, C equals 45 degrees. Draw one of the central angles on the picture, label it with the correct size. Okay, well, one of the central angles, you have to find the center, right? Could be a little hard, so you kind of have to, I guess what you could do is just sort of eyeball it, right? This is sort of where the center is. So if I connect all the corners to the center, they only ask for one central angle. So this would be a central angle, right? And this would be 45 degrees. Okay, so I did that one. That one, calculate the sum of the interior angles. Okay, this is a slightly more difficult formula. So I'm going to look at my formula sheet. It says the sum of the interior angles. Well, that's the sum of the interior angles equals, use my pen, S equals 180 times n minus 2, 8 minus 2, right? Which is equal to 180 degrees times 6. 8 minus 2 is 6. And that gives me 1080 degrees. And I'm just using the formulas on my formula sheet, or you can look in the earlier on the package. and then determine the size of one of the interior angles. All right. Well, that formula, if I find the sum, the measure of one interior angle equals, what I do is I take the sum of all of my angles and I divide it by how many I would have. And I would have 1, 2, 3, 4, 5, 6, 7, 8. Excuse me. And that gives me 135 degrees. Okay. Then it says part E is label one of the interior angles on the picture above. Well, this would be one of the interior angles, right? And you can see it's obtuse. It's a wide one, greater than 90 degrees. So this is 135 degrees, okay? Now, I only assigned one to D. I'm gonna get you to do for homework today. This was yesterday's, do this today. Part 2, it says a hexagon. As soon as I see the hexagon six-sided, I know right away that n equals 6. That's very important. Draw lines on the diagram to show the central angles. Okay, this time they want all the central angles. So that word central reminds me I have to find the center. I'm kind of eyeballing it, to be honest. So here are all the central angles. Guess I could do this too. That might make my job easier. Connecting all the corners. These are also the diagonals, right? And notice I have 1, 2, 3, 4, 5, 6. 6 central angles for a six-sided figure. Calculate the size of the central angle in this polygon. Well, a central angle is going to equal 360 degrees divided by 6, which is 60 degrees. Label one of the central angles. All right. 60 degrees. And 6 of these would create 360, right? A full circle. Okay, so I assigned, I'm going to get you to do the rest of number 1 for homework. And I'm going to get you to do page 15. I'm going to get you to do 3, 4, and 5 on page 15 for homework. Okay, and then we'll revisit this tomorrow. And then I'm probably going to end up giving you a work class Thursday, Friday, because I want to make sure that I give you at least 2 days of work class per week. And because I chunked this out so slowly, I ended up talking for Monday and Tuesday. I'll talk a little bit tomorrow, and then I think I'll give you... Oh, I didn't give page 15 yesterday. Is 1E... Yeah, all I did yesterday was give you one part of number 1 and number 2. I'm going to get you to finish number 1 and all of page 15. The line of symmetry thing I'm going to do tomorrow because I'm just doing concepts like really slow geometry. This is such a dense unit for definition. So yeah, if you want to work ahead though, Cynthia, by all means, work ahead. All we have to do tomorrow, we're going to talk about lines of symmetry, and we're going to try and do some tough problems, okay? So, yeah, take a look at page 15, finish, and that's it for today. I'll stay on a little longer in case there's some questions. I'll stay on for a couple minutes in case you've got some other questions for me. Okay, I will see you either over the internet, you can email me, or leave a comment in the blog, and I'll talk to you later on.